if there's one in that basket. Alright, so today we're going to be doing lesson 3.8, which is the remainder and factor theorems lesson. So we're going to be talking about how these things all coincide. So a lot of this lesson is bringing together a lot of the concepts that we've talked about throughout the unit. As you guys know, per announcement, I've made out announcement, I put out the announcement I think last week. You will have a quiz that'll open on Thursday, and it will cover up to 3.8, so unit 3 up to 3.8, and then you will have a test at the end or beginning of next week. I put up the actual date and all of that on eCampus. I believe it's the beginning for you guys. Yeah. So let's go ahead and get started. So what is the remainder theorem? The remainder theorem states that if you divide a polynomial f of x by a linear expression x minus a, the remainder will be the same as evaluating f of a. So basically what that means is you can divide a polynomial by x minus 4 or x plus 3, anything that's a linear binomial, which we've been doing using synthetic division, and the remainder is the same thing as if you were to plug that value into the function. Okay, that's the same way of two ways of doing the same thing, getting the same results. And the factor theorem states that if you divide a polynomial f of x by a linear expression, x minus a, or it could be, the constant could be negative or positive, the remainder is 0. If the remainder is 0, then x minus a is a factor of f of x. So you guys already knew that. If you divide your polynomial by some expression, and the remainder is 0, that means that whatever that expression is a factor of your polynomial. So let's go ahead and get started on the examples. So throughout this lesson, we're going to be using the same example. We're going to be looking at it from different perspectives. So the longest one is probably the long division. So the rule is if I take this polynomial and I divide this polynomial by the linear binomial, okay? It's the same thing as if I were to evaluate that function at p of negative 1. Before we get into this, I want to make sure you guys understand the relationship between the divisor and p of negative 1. So go ahead and look at these two, and what do you think they have? What do they have in common? Me evaluating at the value x equals negative 1 and the expression x plus 1. How do they relate to each other? They both have what in them? A 1. So the rule is basically your p of value is always whatever this is, but the opposite sign. So you guys see that? So if your divisor is x plus 1, your p value is going to be p of negative 1. If your factor is x plus 2, what is your p value going to be? Negative 2. If your divisor is x minus 2, what's your p value going to be? Positive 2. Okay, so that's the relationship between these two. So let's go ahead and do our long division. So we're dividing this polynomial by this divisor. So you put the divisor on the outside, if you guys remember, it's been a while. And then your polynomial goes on the inside. But before we write our polynomial on the inside, what do we have to make sure that we're not missing? Good, so are we missing some factors in the middle? Are we missing any in the middle? Which ones are we missing? Good, we're missing x to the 4th, and we're missing the x, right? So what do we put in for those missing ones? 0. We put in 0 terms. So we call these the placeholders. So plus 0x to the 4th minus 4x cubed minus x squared, and then plus 0x plus 4, like that, okay? Looks like that. So you always have to put in 0 terms for any terms that you're missing. And that can be up to the constant as well. So now we're doing long division like we learned about a few weeks ago. What would I multiply x by to get to x to the 5th? X to the 4th, good. And you always line it up with its common exponent term in the divisor there, or in the dividend. Then you multiply what you put up here times your divisor. So I'm going to do that multiplication. You can use the distributive property, but I'm going to do it in my head. So x to the 4th times x is x to the 5th. And then 1 times x to the 4th is 1x to the 4th, right? And then with long division, do you add or subtract? Subtract. These are both subtracted away. So this is subtraction and this is subtraction. Okay, they both become subtraction evidently in the end. So what is x to the 5th minus x to the 5th? 0. So I don't have to write anything here. You can put 0 if you want. But it just cancels each other out. And then what is 0x to the 4th minus x to the 4th? Good, negative 1x to the 4th, because the 0 doesn't do anything. Then we always bring down our next term, like this, like with any other long division problem. Now we determine what would we multiply x by to get us to negative 1x to the 4th? Good, negative x to the 3rd. If I multiply negative x to the 3rd, right here, times my divisor, okay, we should get the first terms to cancel out, which they will. So, what's negative x to the 3rd times x? Negative 1x to the 4th. That's what we always want. You always want your first terms to cancel out, which they will. And then what is 1 times negative x cubed? Yeah, negative 1x cubed. Like that. And we're subtracting both of these away, but since they're already negative, what are they going to become when I subtract them away? Positive. Good. These are going to become addition, because when you distribute that negative, it changes the sign of everything, and since they were already negative, they're changing to a positive. And then from here, you're just going to combine like terms. So for the first terms, what happens to them? As always, cancels. And then what is negative 4x cubed plus x cubed? Good. Well, no. 3x cubed. Negative 3x cubed. Very good. And then from there, we need to bring down this right here. Negative x squared, like that. Now we determine what would I multiply x by to get to negative 3x cubed? Good, negative 3x squared. Then we need to multiply everything by negative 3x squared. I multiply this by this. That becomes negative 3x cubed minus 3x cubed, right? Am I subtracting away or adding these two? Yeah, they're evidently going to become adding because I'm distributing that negative 1, which changes the signs of both of these. So then I can combine them. The first term always cancels, and does it cancel? Yes. And then over here I'm left with 2x squared. Next step is to bring down my 0x term. Try again. So what could I multiply x by to get to 2x squared? 2x. Then I need to multiply 2x times this right here, use the distributive property. 2x times x is 2x squared. 2x times 1 is just 2x. Am I adding or subtracting these? Subtracting. They both become subtraction. The first terms do what? Cancel, right? These cancel out right here. And then I'm left with negative 2x. I have one more term to bring down right here, the 4. So the 4 comes down. Now we do our division one last time. What could I multiply x by to get to negative 2x? Negative 2. I multiply my divisor by negative 2, and that comes out to be negative 2x minus 2. Am I adding or subtracting these? Yes, so they evidently become addition because you distribute that negative. And then the first terms do what? Cancel out, and I'm left with my remainder of 6. So at the end, when you can't divide anymore or bring anything else down, you call this the remainder. Okay, that's called the remainder. And our remainder, according to the theorem, okay, it says here, if you evaluate dividing a polynomial, it's the same as evaluating, aka the answer to this is whatever your remainder is. Oops, what is going on right now? There we go, sorry. So yeah, this is your remainder. So p of -2 is equal to 6. So whatever you get as your remainder is the same thing as evaluating the function at that point of a. That's what your a value is. Any questions about how we got that? Did that make sense, the procedure that we did? You should know how to do long division, but it's just a refresher on how to do the long division in case you forgot. Are we good to move on? Okay, so that's the first way you can figure out what p of -1 is, or p of any value. Now we're going to talk about a little bit of an easier way. This is using technology, okay? So I have Desmos open right here, and I'm going to teach you how to type this in. And it's not a bad idea to get some actual practice with this as well, because sometimes you just want to make sure you're typing everything in right. So what you do here is you type in the function as is. So p of x equals x to the 5th minus 4x cubed minus x squared plus 4, like that, okay? And you're going to look at your function. So they want us to evaluate the function at where x plus 2 exists, okay? So let's talk about what that means, this factor. So this factor, okay, if we were to set this factor equal to 0, what would we get when we solve for x here? -1. That's where the p of -1 comes in, and this is the same thing as this right here, okay? That's why it's p of -1. So we're going to look at where the graph is equal to x equals -1. So here it is, okay? So let's look at where the graph equals -1. So we look in and we see where -1 is, okay, on the graph, and we go up and determine where it hits the y-axis at that point. So where is it hitting the y-axis at that point? You guys see that? At 6 right there, see that? At 6. So the answer here is 6, okay? So on your table, you guys can make a little sketch of this. So -1, 6 is like right here. And we can plot some other critical points to get an idea of what this graph looks like. So it also hits the axis at 4, 0, 4, it looks like, right here. And it hits the axis at 0, 2, or 0, 1, my bad. It's one of them is by 5s and one's by 2s, so it's confusing. So yeah, that would be 1. And then it also hits at 2 like this, and it also hits at -2 like that. So your graph kind of looks something like, see what your critical point up here is, something like this. So that's a general sketch of your graph. That's not just a rough sketch. That's just from Desmos. So we wanted to evaluate x plus 1, right? But let's say that I wanted to evaluate the graph at x minus 2. What would you guys do to evaluate the graph at x minus 2? Where am I looking at? What x value am I looking at on the graph? X equals +2. +2. It's always the opposite because you have to set this equal to 0. Okay? So when x equals +2, what's the y value? So we call this p of 2 is equal to, what's the y value for that? Right here. 0. Thank you. 0. And if I wanted to do, let's say x of +2. That's p of what? -2. Where's that hit the graph? 0 as well. So these two hit the graph at 0. So what do we know about these two expressions? They are what of the polynomial? They are zeros if we solve for them, but we call it with word with the F. Factors. These are both factors of the polynomial. Okay? So that's how that all connects. When you have a 0, that expression that you got the 0 from is also the factor of the polynomial. Okay? So it's just kind of going backwards from what you guys are used to. So are you guys good to try another problem where we go into another layer of this? All right. So now we're going to do direct substitution. So direct substitution just means if I give you this expression and I say that this is we want to see if it's a divisor, what you do is you can just plug in a -1. So this is p of -1. So all you're going to do is you're going to replace all of the x's with -1 in your equation. So it's just going to be replaced with everything with -1. This is a -1. Like that. And all I did was I just replaced all of the x's with -1. So for this method, you just have to be particularly careful of your order of operations rules. So in order of operations, what comes first? PEMDAS. Parentheses. Do we have anything inside the parentheses we can do? No. So we move on to the next, which is exponents. Do we have any exponents we can evaluate? Yes. What's -1 to the 5th power? -1. Any negative, no, like -1 to the odd power is always -1. -1 to an even power is +1. -4 times, what's -1 to the 3rd power? -1. And now, what's -1 to the 2nd power? +1. But there's a negative sign on the outside, so it's going to become a negative. But it becomes positive, and then it becomes negative again, only because of that negative sign on the outside. And then we bring down the +4, like that. And then we move on to the next set of order of operations, which is multiplication division. Do we have any of that here? Yeah, we have multiplication right here, right? So this becomes -1. What's -4 times -1? +4 -1 + 4. I know it seems silly, but like this is really common for students to make mistakes on this. So that's why we're going through all the steps. And then we go, this is addition, subtraction. They're even operations. You go from left to right. So what's -1 + 4? Good. 3 - 1 + 4. That's a +3, by the way. What's 3 - 1? And what's 2 + 4? 6. See how we got the same answer as we got using graphing technology and using long division. So these are all same ways to get the same result. So it's just making connections between what's a factor and what's a 0 and all of that stuff. Okay. Now from here we're going to try synthetic substitution, which I would argue is the easiest method, as long as you know how to do synthetic division. So synthetic substitution is very simple. You're going to set it up like you set up a synthetic division problem. Now, what do you always need to do when you're dividing by your linear binomial with synthetic division? What do you do with your C value or your A value? It becomes opposite sign. This is a negative sign, right? That's where the P of -1 comes from. Now we put the coefficients of our polynomial in. So, what is the coefficient of x to the 5th? What's the coefficient of x to the 4th? X to the 4th. That's x. You see what I'm saying?
Yeah.
So we have to put in that 0 placeholder. Everybody understand where the 0 came from? Because this polynomial right here is really P of x equals x to the 5th plus 0x to the 4th minus 4x cubed minus x squared plus 0x plus 4. So you always have to put in all of those 0 placeholders. If you don't do that, your synthetic division will come out incorrectly. So if you're missing anything in the middle, you need to put it in as a 0 placeholder. Then it's going to be negative 4, negative 1, 0, and 4. So everybody see where I got those from. You have to be proficient with the synthetic division. All right, moving on, we're going to do synthetic division. First thing you do for synthetic division, after I wrote down the coefficients of everything, I double check my coefficients, make sure I didn't make any errors. No one's void of error. And then from here, we're just going to complete it. So we bring down our 1, we multiply. What's negative 1 times 1? We add. What's 0 plus negative 1? Good. We multiply again. Negative 1 times negative 1. Positive 1. We add. What's negative 4 plus 1? Very good. Then we multiply again. Negative 1 times negative 3. 3. Then we add. What do we get? We multiply again. What's negative 1 times 2? We add. Negative 2. Multiply again. Positive 2. What's 4 plus 2? 6. Your remainder is 6. Your answer is 6. See how we got the same answer 4 different ways? Everybody good with that? So, hang on. All right, does anyone need more time on this, or are you guys good to move on? Good? All right, let's try some more examples. So now we're going to do an example where we're looking at a polynomial. This is a common kind of SAT type question they might ask you. It says the polynomial p of x equals x cubed plus 4x squared minus 15x minus 18 is a cubic degree 3 polynomial, which tells us that we must have have 3 roots. How do we know that we have 3 solutions right off the bat before we do anything? Anybody remind me how we learned that? How did we know we have 3 solutions here? Good. The degree is 3. The degree on this is 3, which means we'll have 3 solutions. We don't know whether or not those solutions are imaginary or real, or some are imaginary and some are real until we actually get into solving that. But, however, we can tell how many roots there are. You should be able to look at a polynomial and determine how many roots there are, and you should be able to tell what the end behavior is going to look like just looking at it. So, they give us the fact that x minus 3 is a factor of the polynomial, and they want us to find the remaining 2 factors. So tell me what would happen if we divide something by a factor. What is the result of the remainder? 0. Like if I divide 6 by 36. I'm sorry, if we divide 36 by 6, what's the remainder of that? 0. There's a remainder of 0. That must be a factor. So our result here would be a 0. So we're going to do that synthetic division. So if they give me a factor, okay, if you see a factor given, this is very important, guys, listen. They'll phrase it this way. If your factor is given and they say it's a 0 solution, you need to divide by that. So if I'm dividing by x minus 3, what's going to be on the outside of my synthetic division? Positive 3, very good. Now I need to write the coefficients of my polynomial. So it's going to be 1, 4, negative 15, and negative 18. Because as you can see, I didn't skip any x's here. I don't need any placeholder terms. Everybody see why we don't have any placeholders here? Okay, so now from here, we're going to complete our synthetic division. So I bring down my 1. I multiply 3 times 1, which is 3. I add. I multiply. This comes out to be 21. I add, that's 6. And I multiply. And I get 18. Negative 18 plus 18 is 0. So did we get what we expected? Did we expect the remainder to be 0? It's just an arrow. It's alright. You can move up if you need to. You're like so far back. Oh, I gotcha. Okay. So we expected the remainder to be 0 because we knew it was a factor. That's a given. When it's a factor, the remainder will always be 0. Now we need to write out what this means. Anyways, okay. So this right here, how would we write this as a polynomial? You guys remind me? This would be x squared plus 7x plus 6. Everybody see where I got that from? Okay. And this would be times whatever the thing we divided by is, x minus 3. And that's because this right here, if we did this multiplication, we would end up back with our polynomial because multiplication reverses division, right? So you got to put in whatever you divided by. Now we want to fully factor this. They want factored form. They want us to factor this whole thing. So this is fully factored. Can't do anything with it. But can we factor what's on the right further? Yeah, what does it factor into? What are some factors of 6 that add up to what are factors of 6 that add up to positive 7? Good, 6 and 1. 1 and 6. Either way doesn't matter. Order doesn't matter with multiplication. It's commutative. So this is what we call our fully factored form. Triple F. Okay, fully factored form. So they want our fully factored form. So we're going to write it on the line here. P of x equals x plus 1 times x plus 6 times x minus 3. And that's what we call our fully factored form. Now, can anybody tell me what would happen if I actually went ahead and distributed and multiplied these all back out? What would I end up with? Exactly, the original polynomial. Very good. Can anybody tell me how we could find the solutions here? We could set each of these equal to 0. So we'd set each one equal to 0. Now, these are pretty easy to solve in your head, right? You guys know what the zeros would be if I set each of these equal to 0? Yeah. So x would be equal to negative 1, x would be equal to negative 6, and x would be equal to 3. So you're always going to change the signs. When you go from factor to 0, the signs always flip. Make sense? Now from here we want to identify the types of solutions. So, how many of these are real and how many are imaginary? Are any of them imaginary? No. So we have 3 real solutions. And how many imaginary solutions? 0 imaginary. So those define 3 real solutions and no imaginary solution. That's how it works. So, if I were to graph this, where would you expect this graph to hit the x-axis? Very good. So you could also use the graph to identify the same information that we just figured out, right? So let's see. If I look at this graph real quick, see how I hit at negative 6, negative 2, and 3? If you graph it, that's where your zeros are. And if you feel comfortable with this, you could go backwards into factored form. But this one's pretty simple, but some of them aren't going to be quite as simple. So let's move on to the next. So now we're going to do what's called double synthetic division. Okay, it's not hard. It's just you got to make sure you keep everything sorted. So the polynomial has 2 factors. They give us 2 factors. And we want to figure out what the remaining polynomial is or how we can factor it using these 2 factors. So we already know it has these 2 factors, okay? So, does it matter which one I divide by first? No, because if you want me to divide, 42 by 6 and 7, it doesn't matter which one we do first. Okay, we can do either one first. So let's just go in order. So let's divide it by the x minus 1 first. So what's going to go on the outside of my long division here? If we're dividing by x minus 1? Positive 1. Take the coefficients of your polynomial and write them inside. 1, 1, negative 1, 1, and negative 2. So you try to get them to line up the best you can because we want our remainder to go here. So I go through, I double check that I've written them correctly, I'm not missing any x's, and then I can proceed with my long division. First thing you do is bring down your first term. You multiply. What's 1 times 1? 1. We add. What's 1 plus 1? We multiply again. What's 1 times 2? Positive 2. What's negative 1 plus 2? 1. We multiply again. 1 times 1 is? Add. Good. Multiply, we got 2 again. What's negative 2 plus 2? 0. So this isn't totally lined up, but we'll try our best here. So now you already have the coefficients written in this next box, so you can go right into your next synthetic division. Was this 2, 1 like that? I erased it. 2, 1, right? So now from here, I'm going to get these to line up a little better. Like that, because I want it to go over here. So now we're going to do another synthetic division. So what's going to go on the outside of this one if I'm dividing by x plus 2? Negative 2. We're going to do it again. So we bring down our 1. We multiply. What's negative 2 times 1? What's 2 minus 2? Multiply again. What's negative 2 times 0? 1 plus 0? Multiply. 2 minus 2? 0. So we have a remainder of 0, of course, on both of them, which means that they are both what? Factors. So how you write it out is you write your original factors, always. Whatever you divided by, you have to write in, times whatever is left. How do I interpret this as a polynomial? What would that be as a polynomial? 1, 0, 1. It would be 1x squared plus 0x plus 1, right? But can I write this more simplistically? Yeah, I can write it as just x squared plus 1, because I don't need that 0 term in there. Now, this is our somewhat factored form, but is it fully factored? No, we can actually factor it further. So you're probably not sure how to factor this, but I'm going to show you a trick. So let's say you wanted to solve this. You would set it equal to 0, right? And then how would you go about solving this? Subtract 1 on both sides, which would give me x squared equals negative 1, right? Then what would I do to both sides? Square root. What's the square root of negative 1? Plus or minus I. Very good. So this is the solution. So the two roots are, if we write down the first two that we already have, the other two roots are x minus I and x plus I. And if I were to distribute that back out, I'd end up with this. So if you only know how to get the solution, you can just work backwards to get the factor. Okay, just change the sign and put it back into the binomial. So this is what we call our fully factored form. So P of x equals x minus 1 times x plus 2 times x minus I times x plus I, like that. And my solutions are always going to be the opposite of my factor. You just set them equal to 0, right? So my solutions are x equals 1, x equals negative 2, x equals positive I, and x equals negative I. Everybody see how I got my solutions? You just change the sign. To go from solutions to factors, the signs change. Now we identify the types of solutions we have. How many of these solutions are real? 2 real. And how many are imaginary? 2 imaginary. 2 real, 2 imaginary. Any questions about that? What's real, what's not? You guys feel good about that? Okay, sounds good. So we're going to do one more example together, and then we will have time after lunch to work on the 2 assignments. So for this one, we're given this as a factor and we're given this polynomial, so we need to do synthetic division, right? So what's going to go on the outside is a 2, and I take the coefficients from my polynomial, which are 1, negative 8, and 12. Everybody see where I got that from? Ask if you don't. We'll bring down the 1, multiply, combine, multiply, combine, and multiply, combine. We rewrite our original, whatever we divided by, and this is x squared plus x minus 6, or 1x if you want. That comes from this right here. And then are we fully factored, or can we factor this more? More. We can factor the n more, right? So what are factors of -6 that add up to a positive 1? Good, -2 and positive 3, right? So this is our fully factored form. So this is p of x equals, you can write it two ways. You can write it out how I wrote it here, or you can also say that this is to the what power? Second power. Good. So now we find our solutions. So what are our solutions? X equals 2, x equals 2, and x equals -3. You see why it's negative? Okay. And why is it important that I wrote the same solution twice? It changes, what'd you say? Yeah, it would change our multiplicity. You guys remember multiplicity? So if I were to graph this, what's the difference between when we hit the 0 of 2 and the 0 of -3? What's the main difference? Good, so at 2 it's going to bounce, and at -3 it goes through. So I'm going to write that out. So let's go ahead and look at this graph. So we see that it hits the x-axis technically only twice, right? It goes through at -3, but at 2, see how it doesn't go through? It does what? Bounces. That's because of the multiplicity. If a 0 occurs twice, it doesn't go through. If a 0 occurs an even number of times, it bounces. If a 0 occurs an odd number of times, it goes straight through the point. Do you guys see the difference between the two on the graph? Okay. Now we're going to determine what kind of solutions are these? Real, imaginary? All three are real, right? None are imaginary. None have an I in them. So now what I would like you guys to do before lunch is to try the next problem on your own. Do the best you can, and So let's go ahead and try this one, and I'll put up the answers. So actually go ahead and try it. I can come around and check with you guys, but I really want to see that you actually try the problem, okay, instead of just watching me. Don't forget your 0 placeholder terms. X to the 4th would be 1. If it's already there, it's 1. If you haven't put it in yet, it's got to be the 0. To factor this, you're going to have to do factor by grouping. This one's a little bit more tricky. How'd you guys do? Okay, I'll come talk about how to do it. Oh man, I was just so on this question, the first thing that you're going to do here is they tell you the fact that this is a factor of this polynomial. Automatically, if I know it's a factor, I know I can divide by that factor and the end result will give me a remainder of 0. In that event, whatever I get as my result will also be a factor. And if I multiply the factor, the original factor, times what I get as my result of my quotient, that will give me my original polynomial. So I go ahead and I do the division up here. Now don't forget, they're missing the x squared term. That's where the 0 placeholder came from. Everybody good with that portion? The 0, where the 0 came from?
Can you explain that again?
Yeah, sure. So see how here we go x to the 4th, x to the 3rd, and then we jump right to x? Whenever that happens where you have that jump, we're skipping one of the x values, we have to put in a placeholder term for that. So we put in a plus 0x squared, which is why here I took the coefficients 1, -3, and then since I was missing the x squared, I use a 0 for its placeholder. Then I take the -12, and then lastly the coefficient. The constant. And then I bring down the first, multiply, which gives me -1, I combine, and I get -4, and then I multiply, and I get 4, combine, and so on. I did my synthetic division. Synthetic division gives me the result of my coefficients for my polynomial that is another factor. So I take the coefficients, and I write them to create a new polynomial, which becomes x squared, because the coefficient of x squared is 1, you don't have to write the 1. The -4 is for the x squared. The 4 is for the x, and lastly, the one that's always directly to the left of the coefficient, the remainder, is always your constant, like that. Once you get to that point, this is a cubic polynomial, okay? You can't factor it using normal factoring methods because it's not a quadratic, so we have to use factor by grouping. So in the event of factor by grouping, you split your polynomial down the middle, and you factor the left and the right side to see what you can factor out. If I split it down the middle, what can I factor out of the left side here? X squared. I factor out an x squared. That result leaves me with x minus 4. Therefore, if I were to distribute the x squared back, I would end up with my original, and that's how you can always check your work when you factor. Over here, what can I factor out of the right? A positive 4. I factor out a positive 4, which ultimately leaves me with x minus 4. And if I were to distribute that back out, I would end up with my original result. Now, factor by grouping states that, see how here I have an x plus 4 in both terms? I can factor the x plus 4 out of both terms, which leaves me with just what's left on the outside of the parentheses, x squared plus 4 to group together. Now, unfortunately, x squared plus 4 grouped together is not actually fully factored, because it's to the second power. To get it fully factored, you need all of your x's to the first power. So this is actually going to come out as an imaginary root. So whenever you have x squared plus some number, that's always going to be imaginary, okay? Because the only way to get 0 when you have a number squared plus something equals 0 is for that number to be negative, which is impossible. So we take this and we set it equal to 0. We subtract 4 on both sides, and I take the square root of both sides. When you take the square root of -4, you get plus or minus 2i and -2i. And when you go from solutions to factors, you just change the sign and put them back in binomials, and that would be your fully factored form. And then, of course, to go backwards, basically these all just change sign, where you set them equal to 0, essentially the same thing. And as you can see, 2 of these solutions are real, and 2 of them are imaginary because they have the ion. So that one's a little more complex, but how do you guys feel about it? Better? All right, so lunch, and then we'll come back and do it after.